Hi everybody, this was the homework task that I set, not really formal homework, but I asked to do part E and F on the 2015, that's January 2015 preBAC. So what do we have? What's important? Let's highlight certain things. So we now let k equal 4 on the family of functions, so as you can see, if I can make this slightly bigger, we have that is 4, so k is 4 there. That's what that means by letting k equal 4. Calculate the equation of the tangent, that's important when it says calculate, for the point of inflection of f4. Show your working. So, I think it was worth 5 marks. Well, I know it was worth 5 marks. So, I have f4 is equal to 4x over e to the 0.5x. It's a calculator paper, so I can simply just insert a problem, calculator. I'm going to define my function as f1 of x, and it's defined as 4x over e, oops, I have not put that in right, let me do that again, e to the 0.5 x, and push enter. So I've defined it. So f dash 4 of x is the first derivative, and that's all on my calculator, so I can find the derivative function, put that in, and I get I don't think I've got it exact, so my calculator's in the wrong mode, so I'm going to go settings, change document settings, and I want my calculation mode to be exact rather than approximate, and I'll try that again. So I get, yeah, that's a far better one. So it's 4 minus 2x times e to the minus x over 2, and the second derivative is equal to just type it into my calculator, f1 of x, and I get x minus 4 times e to the minus x over 2. That's the second derivative. So I need to solve for the the x value that gives me the point of inflection. So we let the second derivative equal 0 and solve for that. So again, I'm just using the calculator because why not? And of course, x is equal to 4. Now we knew that already because of the part that we did earlier in the question, not E. I think it was when I was doing the thing with the curvatures and all of that. We could use a table of values to confirm that that is the point of inflection, but hey, we've got that already. So we need to calculate the tangent line at that point. So we know that x equals 4. Well, y is equal to 4 lots of 4 over e to the 0.5 times 4, which is equal to, and again, I'm just using the calculator so I don't make any silly mistakes. I don't want to make any silly mistakes at all with this. I'm taking my time. It's worth 5 marks, which is a good 8 minutes or so, maybe even more in the actual exam. So, and now I can say, okay, I know what x is, and I know what everything is. I know that my gradient needs to be done by doing that, and I can use the calculator. I can just define a function as the gradient function. So f2 of x is going to be defined as the gradient function, so the first derivative of f1 of x, that's defined. So f2, I put 4 into my calculator, and I get minus 4 times e to the minus 2, so that's the gradient. So now I have y is equal to mx plus c, so I have y is 16 e to the minus 2 equals m, which is minus 4 e to the minus 2. I know that x is 4, and I need to work out c. So I can just do some tidying here. So 16 over e squared is equal to minus 4 times 4 is minus 16 over e squared plus c. I can add the 16 over e squareds together, so I'm going to have 32 over e squared is equal to c. So we have y is equal to mx plus c. And I'm going to try that on the calculator. So let's type in tangent line, open brackets, f1 of x, comma 4, and I get, oops, x equals 4, silly me, x equals 4, and I get the same thing. I have it in a slightly different format, but they actually have it as y is equal to 32. I say they. Who's they? The calculator? Don't worry, I'm not going to start wrapping. And that's the same thing. These are equivalent. So that was your 5 marks. Okay. So, part F. Consider the region bounded by the graph of g of x, which is 5e to the minus x, the graph of f4, and the line x equals p. Show that there is only one valid value for p that gives an area of 5 units. Give your value of p correct to 2 decimal places. Well, the first thing I'm going to do is I'm going to put that onto a graph page, and then I'm going to sketch it so I can see what's going on. So I'm going to add a graph page. I'm going to plot f1. Oops, my calculator's been a bit funny. And I'm going to define g of x, and that was 5 times e to the minus x. Put that in there. And I need to have x equals p, but I'll put that in shortly, okay? So what do we have? So we have, this is f. We have our function, our axis, that looks something like that. We have one that's doing this. Let me just get this really as nice as I can, actually. Something like that. And then we have the other function coming up like that. Okay. And we have the pink one is f4, and the black one was g of x. And we also have this other function that I'm just going to have dotted green for now, which is x is p, x equals p, this vertical line. And what we have to do is show that there is only one valid value for p that gives an area of 5 units. So consider the region bounded by the graph of g of x, f4, and the line equals p. So what's the area we're looking at? Well, actually, if I just go and make this area, that dotted line a bit slightly bigger, what we're talking about is this area here. Okay, and remember that's x equals p. So I need to know what this coordinate point there is. That will be my lower bound, and we don't know what p is. Several ways of doing this. We can use sliders, we can use everything. In fact, I'm going to put a function into my graph menu, graph entry edit, equation templates, line, vertical line, and I'm going to put the line in P, and I think it will ask me immediately to put a slider in. Yeah, so I say create a slider for P. Okay, now P is not a constant, P is a variable. So I need to work out this orange scribble shaded thing in, and I know that the total area has to be 5 units. So what we're kind of doing is this. We'll put y and x on there first. So the area and it says we want to calculate P. I just want to be sure. Yeah, give your value of P correct to 2 decimal places. So we do the pink one, the area bounded by, let's call this value x1 to be found, x1 to P, okay, and that's f4 of x dx, and that's take away the area of x1 to P of g of x. Now, I know some of you get a bit, you're not quite sure how I've split up. We don't go across, we're not going down here at all. We're not touching that bit there. So I could write this as the area is equal to px1 f4 of x minus g of x dx. It's the same thing. So let's find x1. Well, x1 is the solution of the two functions. So we can solve those directly. I've got those in my calculator. So I'm going to do menu, system of equations, so algebra, system of equations, or solve system of equations, solve system of equations, two variables. I call my equations f1 of x, I let that equal y, and I actually call the other one f3 because I used f2 for something else. Of x equals y. Just made a slight mistake with the bracket there, so fix that, click enter. So, be careful, it says x1, my value can either be, no actually, okay, it says, let me just make sure I got this one right, I want to be absolutely sure, yeah, so, what we can do, actually I'm going to do it a slightly different way. I'm going to find the intersection point. I think that's going to be an easier way of doing it. So menu, analyze graph, intersection of the two functions. So find the two functions. Oh, enter, enter. Go either side of the two graphs, and I get my intersection point, which is 0.827 and 2.19. Go back to the calculator. My calculator was doing something quite strange. I don't know what my calculator was doing. I'll have to think about that. I'll come back to that shortly. Okay, so I know that the area is equal to 0.827 P f4 of x minus g of x dx, and we know that that's equal to 5. I can simply do the following. Solve, open brackets, the integral, lower bound is 0.827, upper bound I'm going to call a because I already used p. That's f1 of x minus f3 of x dx is equal to 5, comma a. Okay. So I get a is equal to minus 0.44 to 2 dp, which is clearly not the right one. Or a, well, it's called p. Sorry, or p is equal to 3.38 to 2 dp, and that's the one I want. There are other ways of doing it, and if I have time in class, I can show you on the calculator how to do it. But anyway, hopefully that helps.